I use a geocast reactor on my tank and on my clients' tanks, and now there's a way to make it more efficient and get more oomph out of that cast reactor. I'm here with Gio, who's going to talk me through the CO2 saturation chamber that you say I should put on my reactor. Tell me about it, tell me why.
All right, so the original reactors had a bubble counter on the side, and the CO2 would be injected into the reactor, but they would go through a loop and go directly to the pump, the recirculating pump of the reactor. And the problem with that is, first, it makes a loud noise, right? So those bubbles are going to churn through the impeller of the recirculation pump, and you have that horrible noise. And we know, like, if the reactor's in our stand, in our living rooms, we don't want to hear that noise. We want it nice and quiet.
Sure.
So that was started, the idea of having its own saturation chamber. Now, the saturation chamber does two things. It's very efficient in the CO2. It doesn't waste CO2. When you compare it to the old style, you're saving about 90% of the CO2. So you're wasting 10% now, where previously you could waste up to 50% of the CO2.
Wow.
And the reason for that is the CO2 that's being injected is isolated in the saturation chamber. There's nowhere for it to go. It has to be soluble into the water column.
Okay.
So that's what makes it very efficient. The other thing, so we don't get the noise, is since that CO2 can't pass through to the pump, since the pump is down here, you're not going to get the gas bubbles from the CO2 into the pump and start to cavitate the pump, and that's what you get, that chopping noise. So then your soluble CO2, it's already dropped the pH, and normally we like about 6.5 pH, is then going to pass through to the main body of the reactor and start to melt the media.
Okay.
And then the water just loops back around.
So I'm using less CO2 because it's more efficient of getting that CO2 dissolved, and it's quieter, and that's going to make also my effluent come out of here more potent because it's doing its job more effectively. But I'm looking at this, Gio, and you have the output right next to the import. Doesn't the CO2 go in and then come right back out?
What happens is that there is a small
there you go.
lip here. So your CO2 is coming in here and comes down the tube inside. There's a little hole there and the CO2 comes out. And so the water's churning in there and you can see the bubbles bouncing around. But what you can't see is the output. So this is where your water is going to come out. The interesting point here is that there is a little lip here of the fitting. It's about 3/16 of an inch. And if we can get a shot of underneath the lid, you'll see that the air bubbles, or the CO2, is not getting to that black port. It's automatically wants to be soluble, so it's being compressed into the water column, and those bubbles never make it to the output.
So the CO2 goes in the chamber, it gets pulled down into the water, it doesn't go straight back out, which is how you get that saturation going.
Now, you can get about 10% loss, so it really depends on how you tune the reactor. And if you're over putting too much CO2 in, then of course it doesn't have enough time to all be soluble into the water column, and you may get about 10% that you're going to lose, which is a lot better than losing 50% from previous models.
There's no bubble counter on here, so if people are using the old method of bubbles per second, how do we count our bubbles in this type of setup, or do you even need to?
We try to let the old timers be able to do the same thing, right?
Yeah.
So we did include an internal bubble counter. So as the CO2 comes down this center tube, you'll see there's a little hole here, and you can count the bubbles coming out.
So you can do it that way if you want to do it the old school method.
Correct. But if you use, we have directions, and then you can just easily set your, depending on the type of regulator you have, you can do pressure and then control it with your pH probe and just set it to a pH, we'll say, of 6.6. plus or minus 0.05 if you're doing a program.
So I already have your calcium reactor. I can add this to my existing setup, or do I have to build something, buy a whole new reactor from you?
We'll be releasing an add-on, which
Okay.
is just a saturation chamber. Now, there's certain models that you have to have in order to put the add-on. And you'll know that by models that have the exit on the side of the body. Older models of Generation 1 have the output and a union on top, and unfortunately we're not able to add those.
But most people, even mine, is going to have side output, so I can add on this chamber.
Correct.
You have it for every size reactor that you have?
Every 18-inch reactor. So if you have a CR618, CR818, or a CR1218 commercial, you'll be able to do that.
So here's a way I can make my reactor do more for me. I'm saving CO2 at the same time. And you even said if we wanted to go nuts and get it down to like 5.5 pH in there, we could do it with the saturation chamber.
Correct. You could even use solid limestone, which is very dense. It takes a very low pH. Some people like to use that. They feel that there's more benefits of doing that because of less possibly phosphate release. So you can use that. But in order to do that, you really got to drop the pH. So you got to be careful.
Geo, calcium reactors have been around forever, and something that was big in the hobby then fell out of favor, but now it's coming back, is ozone. You've got an ozone reactor over here. Show me this thing.
Sure, we'll take a look.
So lots of tiny bubbles here. This is a ozone reactor.
Recirculating ozone reactor.
Why is that better than just putting it into the ozone port on my protein skimmer?
Well, there's two key items very important for getting the ozone into the water column, right? One of them, the first one, is you need a port or a venturi to be able to push the water in a very small opening, grab the ozone and push it into the water. The second item is dwell time.
Okay.
Protein skimmers don't have dwell time. Most protein skimmers have a needle wheel. The water comes in and goes right back out. There's almost no time in there. In a recirculating ozone reactor, we can control the amount of time that the ozone stays inside.
Okay.
There's two items that does that, controls that, is really the water input. So your feed pump that's pushing water into the reactor, if you're using a DC pump, you can control how many gallons per hour are going in and out of the reactor.
Dwell time is important. Getting that ozone into the water column is important. And then also the concern of ozone getting out into the air once it's done its thing in the reactor.
Correct.
And you've got that handled with this off-gas chamber here.
Correct. So what we do is, we know that ozone, obviously it smells very bad and nobody wants to smell it, but it's not healthy for us, right? You can get headaches and you don't want it in the room. So we need to take the water that's coming out of the reactor after it's been cleansed, and we want to separate the water and the gas. The gas obviously is the ozone gas. So in the separator here, you have a little bit of water, and then the majority of the gas has nowhere to go. It can't drain out of the reactor. It's got to be forced out through this tube and then through a 5-micron carbon block. You can't use granulated carbon because it's not compact. It'll force its way in between the crevices, but in a carbon block, it's got to push through the carbon, and the carbon pulls out the residual ozone.
So with your recirculating ozone reactor, we can manage dwell time, we can manage getting the ozone into the water so it's more efficient, it's safer, and ultimately gives us the control that every reefer wants for dialing up or dialing down the ozone.
That's right.
Okay, so how big of a tank is this unit going to handle?
Well, this reactor was built for, you could either set it in a sump or put it outside of the sump, and we wanted to make sure that we could safely control a tank up to 200 gallons.
So there's this component, correct me if I'm wrong, we also need an ozone generator to tap into this unit.
Correct. So here at the Venturi, we have a check valve. Obviously, we don't want water to come out and destroy your ozone generator. So right here at the check valve, you'll connect your ozone generator, and each generator normally has a amount of ozone it can push out, right? Or I shouldn't say push out, but generate. And another good point about this recirculating ozone reactor is that you don't need an added air pump. So you don't need to push air from your generator to the reactor. The reactor is going to automatically pull it in at the venturi.
Okay.
So that's an add, you don't have to add another piece of equipment.
So it's simpler as well.
Correct.
And one of the things about ozone is you can also deconstruct it with ultraviolet sterilization.
Correct.
You guys have some UV sterilizers behind me that also integrate into your sump. But before we go there, walk me through this, how it ties into ozone, and we'll talk about it in your sumps.
Sounds good.
All right, Gio, so you have UV sterilization, which is another way to deconstruct the ozone. Most hobbyists are using UV for managing algae and managing fish disease. What size unit am I looking at with this thing?
A 57 watt UV sterilizer. It's got a 18-inch amalgam lamp and a quartz sleeve inside.
So 18 inches, that's small enough to fit in most people's sumps. You don't need this big 5-foot thing that a lot of the higher watt UVs require.
Correct. This is really good for tanks from 125 all the way up to maybe 200, 250 possibly.
Okay.
Just depends on what you're trying to accomplish with it.
And we can mount it vertically, horizontally. How do I deploy this?
Well, when you first look at it, you think it may look a little odd and you're wondering what this valve is right here. What's really nice about this reactor, it gives you many different ways that you can install it. The way it's configured here is if you want your input water coming through here and your output facing down, what destroys a lot of UV sterilizers is that they get air pockets inside. And an air pocket next to the quartz sleeve will overheat the lamp and then cause it to fail. And so the way to get rid of that is to put a little bleed valve. You run this valve just barely cracked open and it'll continuously get the air out so that it doesn't have that issue.
So is this open with another tube down into my sump?
Correct.
Okay.
This is a 3/8-inch output fitting.
Yeah.
And you just run that down to your sump so it's continuously bleeding out.
And I can rotate 180 degrees and that could be a drain to drain it out when I want to service it.
Correct. You could do that. You could also face the output up, use the valve, like you said, as a drain. Or we could remove the valve and we could have two outputs. So you have one input and two outputs. So this is an aluminum housing with an electronic ballast inside. The housing is sealed, so we're not worried about moisture damaging the electronic ballast. We know we don't like electronics and moisture together.
No.
So we've sealed it and we're using aluminum instead of plastic. So what that does is it dissipates the heat that the ballast is giving off and getting it out of the housing. So what that's great for is it's going to prolong the life of the electronic ballast.
And if we want to service the bulb and the sleeve, we have to drain out the reactor, but that looks like as easy as just turning off the pump to it, the water comes right out.
Correct, yeah, you can just turn off. And the nice thing, another thing is that the fittings that you're just talking about taking off, these are not proprietary. These are made in the USA LASCO fittings.
Okay.
So you can go to your local hardware store and get. So you don't have to worry about if you get an emergency installing and you make an accident gluing them in, you can get them locally.
And I can mount this on the wall, it has brackets, but also we can put it right into your sump if you have one of your UV sumps, because it mounts right in, it's got a place for it.
Very easily, just snap them in, and it also you can still use two of the configurations we talked about. You can keep it as a closed loop, where it's just recirculating inside the sump.
Okay.
Or you can just connect it to your main return pump, and it can be a flow through.
One of the hardest things about UV at times can be where do you mount them? It's got to be outside of your sump. You got extra plumbing. This goes right into your UV sumps. It's got a place for it. It's super simple.
Very simple.
I like it. Lots of great stuff coming out from you, Gio. I've got to make some upgrades to my system, some of these things, and for future tanks, I love the integrated UV. Good work.
Thank you.